Okay, step by step from the homework on Monday night, number 25. -4 is already over there. Make sure the number's over there. Next step. I know I'm going to have a lot of not here's today, but does not bother me one bit. 20, nope. 8, nope. I don't care. 14. Okay, what do you got in next step, Caleb? Can't complete the square unless the x's and the y's are all together. So you take the x squared, match it up with the 8x, and take the y squared and match it up with the -4y. Okay, how do I complete the square? You got to do it twice. You got to do it on the x's and you got to do it on the y's. So what's the first step in this process? Do I have a 19? Okay, here we go. What do I have to do over here with the x's? Not the 8x, just the 8. Okay, you take half your b value and square it. So what new number do I get there? 16. So x squared plus 8x plus now 16. And now I'm going to do it on the y's. So please do the same thing for the y's for me. 24. Perfect. Do the same thing for the y's. So I'm going to have y squared minus 4y. Take half the b and square it. What new number do I get back? Plus 4. Yep. And I worry that you're going to forget this step. It's unbalanced. It's unbalanced. What do I still have to do to the right side? 11. 19. What do I still have to do to the right side? Whatever you added to the left has to be added to the right. All right, keep it going. Now I need to do something with this right there, x squared plus 8x plus 16. Now we're going to start making it look like the circle equation. 11. No. Let's keep this train going. 17 in the house. How do I go from here to here now? Half your b value, whatever half the b value originally was, so plus 4 squared. And then what about for the y's? Here you go, 3. Y minus 2 squared. Got it. And then over here, it looks like we'll have what there, 16? Going to say this now. Hey, this one right here, that number never negative. Because what's this number represent in the circle? Radius. How can you have a negative radius length? All right, it's not, can't happen tomorrow. Can't have a negative number. All right, what's the center? So you could graph it. What's the center of that circle? 4, center of that circle. -4, 2. And then how about my radius length? How about 27? Nope. How about 19, radius length? There's a 16 there, so the radius must have been? Take the square root, 4. And then you can easily graph it with your compass. It's on there tomorrow. I don't know what you want me to tell you. It's on there twice tomorrow. It's on there twice. Okay, can I send you practice examples? Yeah, reach out to me. Okay, I'm letting you know it's on there twice tomorrow. Questions there? All right, that's the only one I wanted to do from that homework. Is there anything you wanted to add others than that? Yep. 20. That was another completing the square. Okay, where did we get lost then? Now that I just went over this one, where did we get lost? Okay, what was the original one? What was the original? Anybody have the original for 24 written out? Equals -1. Okay, so you did x squared minus 4x. What was the number you added to that one? Okay, what's your b value? -4. Take half of it. Square it. This should always, this number, because you are squaring, this number you add on should always be positive. Because if it's a negative or a positive, when you end up squaring it, it's always positive. All right, and then I have y squared minus 2y, and then, all right, go ahead, take half your b value here. Square it. Okay, what did I just add to the left side? So what's the R value going to be over here? 4. Okay, so the radius should be 2. Others? Okay, I'm a little nervous watching people write down as fast as they can on their paper. It might catch on fire, and there's 2 of these on there tomorrow. I'll be after school today if you want to get some help on this. Anything else from that homework? Equations of circles. Yep.
So if we can't factor, like if it's a bad equation for factoring.
What do you mean a bad equation for factoring?
Like if it's a decimal or something like that.
I'm not going to do that. I'm not going to do it. If you can't factor it, it's your own fault because you didn't take half your b value and square it correctly. Okay? Honestly, that's the way it is. If you have a number here that you can't do this to, x minus 2 squared, then you did something wrong with half your b value squared. Okay? The quadratic formula?
No, like are we going to need to use the quadratic sometime on the test?
So this has not, your question right now has nothing to do with this. You're onto something new, I think. Because you just started busting out quadratic formula, which has nothing to do with. I will get into that in a second, and the answer is you may. All right, I'll get into that in a second. Anybody else with the circle stuff? Going. Anybody else with the circle stuff? Okay, any construction you want me to review from yesterday? There will be 1 construction. How many did you do yesterday? 4? You did tangent to a circle. You did a square inside. You did a hexagon, and the last one was a triangle, right? Basically, the hexagon and triangle are the same one. One of those 4 will be on there tomorrow. I'm guaranteeing one of those 4 I'm going to ask you to do tomorrow. Yes, Billy?
For the square?
Yep. Draw a diameter and bisect it.
Yeah, do we have to find the, like, does it matter which way we do it?
As long as it goes through the center. I'll give you the center on the, if that's tomorrow, I'll give you the center. I'll give you the circle. You got to draw the diameter in first, and then you got to bisect it with your compass. And then you got to connect all the chords. Okay, one of those 4 on there tomorrow. Anything you want to ask about those 4? Because unless you want to review one after school today, I'm not going to review that tomorrow, but one of the 4 on the quiz tomorrow. Okay, I need to see both right now. I need to see packet, need to see the circle work before we start reviewing for tomorrow. Out already. First, go to page 51. We're going to do some of these today, but starting on page 51 is the review for the quiz. Okay, every theorem that you may need for a proof is on pages 51 and 52. Okay, we'll go over some of those theorems today when we try out some proofs. And then you have, we're not joking around, huh? 26, 27 problems to try out. I'm not correcting them tomorrow. You guys have the answers on pages 61 on. Okay? And like I said, I'll be here after school today. All right? All right. If you want to copy this down, you can. If you want to watch the video later, you can. I don't care what you do at this part, but I'm going to show you exactly what's on the quiz and go over it right now. Okay, here we go. First thing we just went over, writing equations of circles, and I am going to ask you to complete the square. Two different problems will be completing the square. Okay, 2 different problems. Excuse me. So be ready for that. I think I'll tell you the very first question on there tomorrow is I graph a circle. What's the equation? Very first one tomorrow. I'm going to graph a circle for you. You got to give me the equation of it. All right. Next one, 2 theorems involving tangents. Ready? Here's the 2. And I'll go back and forth. I'll leave this up when you guys are ready to work on your own. 2 theorems involving tangents. Here's the first one. First of all, what is a tangent? Let me open that up to you guys. You guys are taking the quiz tomorrow. 12. What is a tangent? Good definition. What's the point where it hits the circle? Point of tangency. Here's the first theorem you should know about the tangent tomorrow. What happens if I connect it to the radius? It is perpendicular. A radius drawn to a point of tangency forms a right angle. Boom. All right. A radius drawn to the point of tangency forms a right angle. Second theorem about a tangent. That'll be covered tomorrow. I think no, I'll do it this way. What is that? Okay, let's try this instead. I know it kind of intersects. I apologize. What do you know here? Those are two tangents. $18, what do we know? One more time, because that's perfect what I want you to write in your reasons column. Two tangents drawn to the same point are congruent. All right. Everyone good on those two? You may have to write them in a proof. You may have to use some algebra with them. Lengths of chords, tangents, and secants. That's what we've done when we did the chords right before break, so I'll review that right now. And then Monday in class, no, never mind. We did both of them before break, so maybe a little foggy. Lengths of chords, tangents, and secants. All right, ready? A, B, and CD, what are they? They intersect. What do I know? Like if I start putting a label like 2, 5, 6, and X, what are you going to do? Use the segments instead. Use the segments instead. 10, we got a 10 in the house. There we go. What do I know? And that's not for this, not for chords. That's for secants and tangents coming up. This one is part times part. So give me 2 parts of a chord. AE times EB is the same product as DE times EC. There we go. That's 2 chords, everybody. 2 chords. Okay. Watch out for this too tomorrow. What's AB? That's the center too. Diameter, but it's still what? Chord, so I can still do part times part. I want somebody to do that for me right now. I'll just put an O there, maybe freak somebody out. Oh boy, this is suspenseful. 11, and it's even going to be more suspenseful. 4, part times part for me. What do you have? Okay, nope, I got it. You don't go from the center, you go from the point of intersection. EA, and what's the other part of that diameter then? Here's AE. What's the other part? No, it goes all the way. Everyone see that? All right, I don't go from the center. I go from the point of intersection of the 2 chords. So it's AE times EB, the entire rest of it. And then what's the other for the other chord? Everyone good there? Okay, so watch out. We can still use it with the diameter. What do I have here? Question out to everyone. What do I have here? 2 secants. Now it's not part times part. Now it's whole times external equals whole times external. All right. So what do you got for me there? 7. Good job. How about, whoa, here we go. 16. We got a 16? Okay, give me the segments, Thomas. That will be whole times external in my diagram up here. Yep, times. Got it. EC times. There you go, got it. Two secants, what's this right here? Secant and a tangent, still whole times external. What would it be then? Oh, 21. 3. Oh, fancy one there, huh? DC times itself. Look at that. Fancy. DC squared. Good. Anything else? Whew, that was just what, number 3 on my list? Construction. I already told you. One proof. We're going to do 2 of them today. And then, Thomas, your question. You may have to factor or use quadratic formula after you set a whole times external problem up. I'll let you know, too, you're going to be able to factor it. Whether you want to try that or not, it's up to you. You can use quadratic formula. All right, but I am going to tell you, you're going to set up a whole times external question tomorrow, and you're going to have to factor it. Whether you choose to factor it, that's up to you. Whether you want to use quadratic formula, that's up to you, too. All right? And then big dog circle question. What do I mean by that? Quiz 2, part A, B, C, D, find all the angles. Okay, that is in your review. Okay, that if we get to it today, we'll get to one of them, but that's in your review. Okay, so floater, inscribed, central, outside, tweener. All right, one of those will be on there tomorrow. Woo! Any questions for you before we tackle a proof? Anything? Whew. Hi, Nam. Always provided to you. Always provided. If it's on the reference sheet you get for the Regents, I'll provide it for you. You're better than that, though. I expect you to factor tomorrow. Got it, boss? Anything else? All right, ready to proof it? Because that's what I want to focus on today are the proofs, because we haven't gone over too many of them. All right, let's roll 27. Here we go, proof 27. Well, you guys have a different 27. All right, I'll go to that one then. You guys have a different one, huh? Okay, I'll get it. Give me a second. It's a good proof. Whew, it's a beast. You guys can start looking at the givens. Mark your diagram if you want. Look at what we need to prove. All right, here we go. Really, the only thing I can mark in my diagram are the parallel chords. And hopefully we remember. If not, we'll know it for tomorrow. If 2 chords are parallel, something happens. Okay. All right, proof statement. Prove to me this line segment BE and CE all year long. All year long. If I've asked you to prove line segments, you're probably going to have to prove what first? A pair of triangles. Absolutely. So we can end this thing with CPCTC. All right, can we find 2 triangles that contain BE and CE in them? Can we find 2 triangles that have BE and CE in them? There's a lot there. I know, I get it. This one's a tough one. But can you find 2 triangles? One triangle that's got BE, another triangle that's got CE in it, that look like we can prove them congruent? Hi, Nika. How are you? I'm doing well, too. Thanks for asking. What 2 triangles? All right, here we go. There they are, kids. Those 2 bad boys right there. How many methods do we have to prove them congruent? 5. I'm not going to list them out, but we have 5. All right, so can you get me any angles or sides? Can we just take care of them right away? Sorry to steal somebody's thunder. Yeah, go ahead. You can throw the verts in right now. That doesn't impress me. Sorry. I need some circle facts now. BEA and CED are congruent. Okay, you got a pair of angles. Hello.
ABE and DCE are right angles.
DCE. How do you know they're right angles?
Because if you look at the blue line, like CEA, that blue line is drawn, both are drawn to a triangle.
Pretty clever there. Here's what he's saying. Look at angle ABE. What type of angle is that? What do we call that in the circle? AB, or let me go ABD then. ABD. It's inscribed, isn't it? And it's drawn to a diameter or a semicircle, so it should be a right angle, but I'm going to bypass all of that. Here's why. What arc is angle ABD drawn to? AD. What arc is DCA drawn to? Same arc. What do I know about two inscribed angles drawn to the same arc? Okay. You could take a look too. Hey. You could also use that on these two angles here, because these two inscribed angles are drawn to which arc? BC. So you could have used it on those as well. All right, but I'll take the one Christian just gave us, which was angle ABD is congruent to angle DCA. All right, what are you going to write here? We talked about it, but what's the correct wording? What type of angles are they? Inscribed angles. What's happening to them? Drawn to the same arc. Are congruent. Nice job. Everyone all right there? Okay, you're going to have to get me a side, though, because angle is not a way. Never will it be a way to prove triangles congruent. I'm going to need a side somewhere. Nobody touched the given yet. Say that again. Okay, here was the theorem. If the chords are parallel, the arcs in between are congruent. Let me say that again. If the chords are parallel, the arcs in between, so in this case, arc BA is congruent to arc CD. Ooh, what's that? We haven't written that theorem yet in a proof, but what did I give you? Parallel chords. I like chords a little better. Parallel chords imply what? Congruent arcs. I'm fine with that. Now get me a side. If the arcs are congruent, so are the chords. What chords in particular? BA and CD. So if the arcs are congruent, so are chords BA and CD. How do you write that one? What did I get? What do you have? Dylan, what do you have? Well, you prove congruent arcs, imply congruent chords. Two more steps. I think you guys can finish it from here. Tell me the triangles that are congruent. I'm going to need some method, though. Triangle. What do you got there? ABE is congruent to triangle CED. Anybody got a method there? Because it is a specific one. What do you got, Sam? That side's not in between. Good. So it's angle, side. And then we finish this sucker up with CP, CTC, BE, and CE. All good there? Hey, I know it's going to be, proof is probably the toughest part tomorrow because it's remembering all those facts, but at least on page, what was it, 51 and 52? I listed all the facts there for you all in one spot. Proof before that one. Here we go. Proof before that one. Looks like this, correct? Okay. This will be the last one, and I'll save that final one for you to do on your own if you feel like you need to. Not much in the givens. I got a secant, a diameter, and a tangent. That's it. What's the only way we're proving them similar? Angle, angle. It's the only way. Only way we're going to prove them similar. So I need your help getting a pair of angles that are congruent in each of those triangles. Look what triangles I'm looking at too. This one inside the circle and the big one. Okay, those are the two I'm looking at right now. Bless you. Got to give me two angles that are congruent. What's up, Thomas? Got one for me?
Yes. They require proving themselves.
What do you got?
Like A, B, C, and B, B, C.
Okay.
Right angles.
Okay, there you go. There's two right angles in this diagram for different reasons, though. Okay, first let me start with why DBC is a right angle. We've already mentioned this today. Last proof we actually mentioned it. It's your proof here so far, Thomas. So go ahead. Hold on. Angle DBC is a right angle. What do you got? What's the reason, Thomas? It's what? Well, what type of angle is it before it was a right angle? Inscribed angle. Where was it drawn to? Okay. Diameter semicircle is a right angle. And you also mentioned another angle that was a right angle. Which one? And I'm not going to ask you why. I'm going to ask your classmates. Why is this one a right angle, everyone? It's not inscribed, so can't use the same reason. It's not inscribed. If you want to talk it over with anybody who's in your group, go ahead. But why is ADC a right angle? We have gone over this theorem today. I reviewed it with you before. Why is that a right angle? I have reviewed it with you today. What do you got? Billy. Diameter drawn to, what's that point called? There you go. Diameter drawn, or radius drawn to a point of tangency is a right angle. Nice job. All right, nice job. We're done with the circles. What do I have to say about the right angles, though? If I'm going to go angle, angle, I got to say what about them? I can't just say they're right angles. That doesn't count. So I got to say they're congruent. Old school reason. What do you got for me, kids? Old school. Yep.
Angle C is reflexive.
I'm not even where I wanted to go there. I'm looking why DBC and ADC are congruent.
Right angles are.
And you just totally stole my fire on the next one. The next angle you need, an angle has nothing to do with the circle fact. It's just the fact that they both share angle.
Angle C is reflexive.
Yeah, that's still not the answer, but okay. Angle C congruent to angle C. Reflexive. Whew, now we could say they're similar. Don't write congruent, embarrassment. Okay, I have a little advanced knowledge of this quiz tomorrow. I just have a couple advantages considering I made it up. So I'm going to ask you the following questions that may or may not help you out for tomorrow. Let's say I extended this proof. And I wrote a proportion here. Reason? Reason why those two are equal? Let's say I extended it one more step tomorrow. And I went times, I don't know what it would be, but this. What would be my reason here? Okay. I don't know. I just have some knowledge. You never know. That may come up. Who knows? Okay. Everyone all good? I guess I kind of already revealed what type of proof it is tomorrow. So I don't know what you want to do with that. Got a calculator on you? Calculator, and you're going to get on your feet for this one. We need to change it up a little bit here. A little excitement to end class. You're going to think on your feet right now. All right, so grab make sure a calculator's in front of you, and you stand up for me. I don't think this is number 20, so I get a little help on which one this is. Number 20. It is number 20 in your packet. Number 20, everybody. Number 20. This is one of those big dog ones. You got to think on your feet now. If you can think on your feet right now, you can do the one on tomorrow's quiz. Sitting down in a nice, comfortable position. All right, let's get going. Everyone see the 4 arcs that are in a ratio. 5 to 4 to 1 to 2. Here we go. Let's start thinking on our feet right now. I got 16 in the house. Great. What am I going to put on arc BC? They're all in a ratio of 5 to 4 to 1 to 2 in that order. So what? So for BC, 5x. How about CA? 4x. How about arc AN? Just x. And NB? 2x. Done. Thank you. Here we go. Next up. 6. So I have a 6 in the house. What can I do with all those arcs? Yep, because I need to know the arcs before I tackle the question. So everyone ready here? 2x plus x plus 5x plus 4x equals 360. All right, someone's going to solve that beast for me. That's why I got calcs out. Hey, 2 in the house? Yeah, it is. How many x's do I have here? 12x equals 360. X equals 30. All right, you're going to go around the circle for me here. So let's start with BC. 150. How about AC? $120. How about NA if you have to go to your calculator? 30. And how about NB? All right, we got all the arcs. We should be in good standing now. All right, you guys ready to roll? Part A, we answered already. Arc BC, $1.50. Here we go. ABC. Everyone take a look. Don't get nervous, man. It's okay. ABC. Here we go. ABC. Look where it is. Look where it is. Oh, 4. Inside or outside? Inside. Is it a central? Inscribed. What's the rule for inscribed? Take its arc, divided by 2. What's that angle measure? 60. Remember to write it in tomorrow. It may help you down the road. Perfect. What's C? NMC now. Angle NMC. Woo, who's up? 10. I got a 10? Darn right I do. NMC. Let's see where that bad boy is. Inside or outside? Outside. There's only one way to find an outside angle. You remember? No. Whoa, we're talking angles here. We're talking angles, though. 1/2. What do I do with the 2 arcs in between if the angle's on the outside? Subtract. All right, you better watch yourself here. If you need highlighters tomorrow, use them. What's the bigger angle in between there, Christian? Because it's not 120. It's a little more than that. 150. Everyone see it's actually NAC? So I got 150. What's the smaller angle? 60. What do you got for me? What is angle NMC? 45. Boom. Everyone all good? D. NDA. Look where that is before I call on somebody. Angle NDA. We are moving. Oh, we already went, Paul. Here we go. 8 in the house. Great. 17? Yeah. Inside or outside? Central. Sorry. I'll just get right to it. Floater. How do I find a floater? Ooh, minus is on the outside. Plus for floaters, plus. What arc belongs to NDA? What's the angle measure? Or the arc measure that belongs to NDA? 30 plus, what's its vertical angles arc? 150. Go, you're up. 30 plus 150, take half of that sucker. Ooh, it was a 90-degree angle. Look at that. Yeah. And then what do we got left here, kids, to finish this off? MN. Oh, boy, this is probably going to be a crazy one. Was it ND? Good talk. MND. Ooh, boy. Oh, boy. Stud here. 25? We got a 25.
Yeah.
Inside or inside, outside?
Inside. Outside.
Nope. Outside and inside. It's a tweener. Ready? Everyone see that? It's not inside, it's not outside. Little tweener. Ready? We're not off the hook, Mason. What is MN? And what's ND or NC? Chord. We have a rule. Tangent and a chord. Half the arc in between. Half the arc in between. Do you see the arc that's in between angle MNC? What is it? What'd you add up?
60 plus 50.
Yep, everyone see that? If I highlight it real quick, settle down. I'm not done yet. Everyone see that arc and how 60 and 150 are in between? So yes, you are going to take half of, what was it, 210? What do you got for me? 105. Yep. There's a whole bunch more on there too, and you also have the 45 I left up on Aspen. All right, get ready for them. I'll be after school today, guys. All right. Compass tomorrow.